Good evening. I'd like to welcome us to this session. I'll be taking us through our system, and a subtopic in this, I'll be taking us through corona effect. And a corona effect is maybe something you have come across it at some point through transmission lines, but you never knew what it is. But by definition, I can say corona effect is a phenomenon of violet glow, hissing noise, and production of ozone gas in an overhead transmission line. So what we refer to as corona effect. And clearly as seen from the picture displayed is that you have ever come across this scenario where the transmission line at some point produces some glowing within it, and of course some certain factors or weather conditions. It's when it appears. Then and a brief theory behind it is that some ionization is always present in air due to cosmic rays, ultraviolet radiations, and radioactivity. Therefore, under normal conditions, the air around conductors contains some ionized particles, that is, free electrons and positive ions and neutral molecules. Of course, this is usually, or this is obvious that o- under some conditions in the atmosphere under some conditions in the atmosphere, there is ionization of the air due to cosmic rays, as we have said, ultraviolet radiations and radioactivity. And these are the factors that are bringing what we are referring to as a corona effect. And so, yeah, this is an infographic just to show us, and then a continuation of the brief description is that when PD is applied between the conductors, potential gradient is set up in the air, which will have maximum value at the top of the, maximum value at the conductor surfaces. Under the influence of potential gradient, the existing free electrons acquire greater velocities here. The greater the applied voltage, now this is what brings in the difference. The greater the applied voltage, the greater the potential gradient, and more is the velocity of the free electrons. This takes place, when voltage passes through the conductor. The more you increase the voltage, the higher or rather the greater the potential gradient across that conductor, and that hence causes the velocity of the free electrons to increase. An example is given of about 30 kilovolts per centimeter. That's at a maximum value. The velocity acquired by the free electrons is sufficient to strike a neutral molecule with enough force to dislodge one or more electrons from it. So this produces another ion and one or more free electrons, which is in turn are accelerated until they collide with other neutral molecules, thus producing other ions. Thus the process of ionization is cumulative. The result of this ionization is that either corona is formed or spark takes place between the conductors. Factors affecting corona are as follows. Atmosphere. When you talk of the atmosphere, we are talking of the amount or the quantity of moisture content in the air, or rather the weather, that is the windy. Yeah, we talk of the windy weather, and the level or the quantity of the moisture in the air. The conductor size, as we have discussed there above, is that the bigger the conductor size, the cross-sectional area in terms, the greater the voltage drop across the conductor, and hence the greater the the voltage drop, the potential gradient, hence increasing the velocity of the free electrons, the spacing between the conductors. This one we shall do some calculation as we go ahead, looking at the corona effect, and of course the line voltage. You have given an example of 30 kilovolts per second and the effect it has. So the advantages and disadvantages of corona. We begin with advantages. Due to corona formation, the air surrounding the conductor becomes conducting, and hence virtual diameter of the conductor is increased. The increased diameter reduces the electrostatic stresses between the conductor. And the second one is that corona reduces the effects of tractions produced by surges. Disadvantages: corona is accompanied by loss of energy. This affects the transmission of the efficiency of the line. Ozone is produced by corona and may cause corrosion of the conductor due to chemical action. As we discussed earlier, that the corona is brought about by creation of ozone around the conductor, the glowing and the hissing sound. So this ozone produced by corona may cause corrosion of the conductor. Of course, that's true due to chemical action. The current drawn by the line due to corona is non-sinusoidal and hence non-sinusoidal voltage drops occurs in the line. This may cause inductive interference with neighboring communication lines when the current drawn by the line due to corona is non-sinusoidal and hence non-sinusoidal voltage drop occurs. Of course, that is automatic. It will affect the communication lines. For instance, if we have a transmission line passing at a certain place, and of course we have a communication line. So when corona effect happens or takes place, it affects the transmission line. Having looked at the definition, the factors affecting the brief theory, bringing about corona effect, I can leave this assignment to you. It's not a hard one. You can do some Google. Explain the methods used to reduce corona effects. And of course, this brings me to the end of my presentation. Thank you.